Every year, 8 billion tonnes of marine litter and macroplastics enter our oceans. Millions more tonnes are already out there. If no action is taken, this number is expected to double by 2030 and double again by 2050, destroying our ecosystems, health and economies. But this doesn't have to be the case. At Team Andromeda, we envision a world where clear rivers flow, the ocean runs blue and everyone can enjoy Earth's natural beauty. And this is because we recognise that any solution must fully leverage technology and evidence-based research. With this data, the benefits are obvious. First, we can optimally direct existing cleanup efforts. And second, we can track the activity of major polluters to develop legislative and social solutions. Given that most ocean plastics concentrate with just 1 metre of the surface, and given that plastic hotspots move little over long timescales, the solution is clear. Our team aims to combine hyperspectral imagery with machine learning to detect these very regions and enrich the world. In addition, we believe our data serves valuable business applications due to climate change and polar ice melt. This allows us to lead the pack in pollution-related consulting for these hence emerging marine industries. This expertise is invaluable to industry and governments alike.
So laying out the first steps to this vision, our team created a software and a hardware demo during the hackathon. For the software component, we designed a machine learning algorithm to identify plastic from space. As labeled satellite images of ocean plastic are scarce, we created a synthetic data pipeline to generate lifelike RGB images.
In parallel to the software component, we 3D printed the chassis of a 1U CubeSat to enclose our preliminary design, which includes a Raspberry Pi development board, OpenCV AI camera, and a power supply. This setup runs a plastic bottle object classification algorithm as a proof of concept for our vision.
Due to the lack of available dataset, we spent a large part of our work to create our ocean plastic dataset. The data generation pipeline uses Sentinel-3 ocean imagery, combining that with samples of generated plastic waste to create a dataset with over 10,000 labeled images. We then use this dataset to train our deep neural network, which is a convolutional UNet built using transfer learning techniques using weights from a ResNet32 pre-trained model. As seen on the screen, our model was able to successfully identify and segment the plastic waste from a satellite image.
Although our work is just a proof of concept, we believe that it paves the way for a fully functional satellite. Our efforts this weekend are a great step towards our vision of a bright and clean future for all.